Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum dear students. This is Shahroz Abdullah, and now today we are going to discuss the terms associated with simple harmonic motion. If you remember, in the first lecture we have discussed motion, its types, then we came to vibratory motion, then we discussed simple harmonic motion, the basic criteria, and some derivation of it in the previous lecture. Okay, now we know that simple harmonic motion is the type of vibratory motion in which acceleration produced is directly proportional to the displacement from the mean position. This was the previous knowledge that we already know. Okay, we have discussed yesterday an example of mass attached to a spring, in which there was a mass attached to a certain spring and it was oscillating about the central or mean position, and there was a restoring force which brings the body back to its original position. This was all the things that we have done yesterday. Now today we will start with some of the terms associated with simple harmonic motion. The first is cycle or vibration. So we can say that cycle or vibration means one complete round trip of a body. If a body starts from a certain point, reaches to another point, and then come back to the same point once again, right? So this is one complete round trip of a body. How can we say that? One complete round trip of a body called cycle or vibration. Okay. Then we have time period. So time period is quite from the word, it is very clear. Time period means it shows you certain time. So we can say that the time required to complete one vibration is known as time period. So what will be time period? The time required to complete one vibration. The time required to complete one cycle or vibration called time period, and time period is represented by capital T. Okay, the unit of time period is second. The unit of time period is second, represented by S. Okay. Now, what is frequency? Frequency means how many vibrations are completed in 1 second. So, in other words, we can say that number of vibrations completed in 1 second. Wherever you hear the word frequency, so do understand that how many vibrations has been completed in 1 second. So this will be frequency. Okay. The number of vibrations completed in 1 second known as frequency. Frequency is represented by small f. Okay. And the unit of frequency is cycle per second, C by S. You can say vibration per second. The SI unit is SI unit of frequency is hertz, represented by Hz. Okay. Now, what is the basic relation between time period and frequency? So do remember one thing, that time period and frequency are inversely variated to each other. Look, T is equal to 1 over F, or we can say that F is equal to 1 over T. Okay. Now, next point is displacement, and the last one is amplitude. There is a difference between amplitude and displacement. Up to some extent both are same as well, just there is a difference of a single word. In displacement, we say the distance covered by a body from mean position to any of the extreme positions. In yesterday's example, mass attached to a spring, we were starting from mean point and reaching to a certain A point and then to A dash. So from A to O, or in other words O to A dash, both can be displacements, right? So in displacement we say the distance covered by a body on either side of the mean position is known as displacement. The distance covered by the body on either side of the mean position is called displacement. Displacement is generally represented by x. We represent it by x. Since it's a distance, so definitely its unit will be meter. And it is represented by m. Then we have amplitude. We represent amplitude by x naught. Now, what is amplitude? Actually, displacement and amplitude both are same, but the only difference in amplitude is that it is maximum displacement. Okay, the rest of the definition is same, just a single word is added over here, that is maximum displacement. So we can write that the maximum displacement covered by the body on either side of the mean position called amplitude, and we know that since it is also a distance, so definitely its unit will be also meter. Okay, so this was terms associated with oscillatory motion. You can say terms associated with simple harmonic motion. So these were some terms we have done with yesterday. Okay, thank you so much. Thanks. Now we are going to discuss a relationship between time period, frequency of mass spring system. Okay. Now we will discuss that how we can relate the time period and frequency of mass spring system. So we are going to discuss a special relationship between these two terms. So we are going to derive that, right? So in simple harmonic motion, we have studied that acceleration is directly proportional to the displacement from the mean position and always directed towards the mean position. So this was the expression A directly proportional to minus x. Okay, when we remove this proportionality sign, we introduce a constant over here, and the constant over here is 4 pi square divided by t square. So we put a constant over here, then multiply with minus x, so you are going to get this expression. Say this is your equation number 1. Okay, now again we use the same expression. A is directly proportional to minus x. We remove this proportionality sign and then introduce a kind of a constant, and the constant value over here is k by m, right? Okay, so we put k by m over here and we then multiply with it, we reach to this destination. This is equation number 2. Now if you see equation 1 and equation 2, both sides are equal, so we can compare both the equations. So this equation and that equation will become equal. So if you see, minus on both sides will be finished, x on the both side will be finished. We will be having k by m is equal to 4 pi square by t square. Okay, now to find out the time period, what we do cross multiplication over here. So this t square will be multiplied with k, we will get t square. K is equal to this 4 pi square will be multiplied with m, so we will get this. Now we will divide this this k value on both hand side. So after dividing, this k will be finished on both sides, so we will get t square is equal to 4 pi square m divided by k. Okay, now we will take under the root of both hand sides. So t square under the root is equal to this thing. So t is equal to, we are going to get 2 pi under the root m by k, which is the basic equation for time period of a mass spring system, right? And what will be the expression for the frequency? Since in the previous lecture we have already discussed that time period and frequency both are inversely variated to each other, so t is equal to 2 pi under the root m by k, so the same inverse expression will be used for the frequency, like f is equal to 1 over 2 pi under the root k by m. So that is all the relation between time period and frequency. So these two expressions will be used to solve the numerical problems related to mass spring system. Okay, thank you.